friends, I am Tushar Gujarati and I welcome you to all to my YouTube channel, My Metallurgy. In this video, we are going to discuss about specifications of steel. So let's start with this video. So friends, we'll see the specifications of steel. It is also called as designation of steels. So basically, steel is specified based on criteria such as chemical composition, manufacturing method, mechanical properties, heat treatment, etc. So every country has a different way of specifications. Majority of specifications are based on chemical composition, because the chemical composition throws light on the probable heat treatment that can be given and the resulting mechanical properties. So chemical composition is one of the important designation criteria which gives us heat treatment and mechanical properties. As well as designers and purchasers have to specify their requirements according to these specifications or designations. So what the designers and purchasers show the requirements according to chemical composition and mechanical properties usually. Therefore, it is necessary to have some knowledge of these specifications. And every country has its own method of designating steel, correct? So, the knowledge of these specifications also helps in selecting a proper type of steel from those available in the market for particular application. Okay, so depending upon application, we have to select proper steel, and to select that steel, we should have knowledge of specification of steels. So we'll see one by one. Some designation systems are there. We'll see one by one. So this is first system is there, Indian Standard Designation System. It is also called as IS, Indian Standard Designation System, ISI. It is adopted by AISI, Indian Standard Institutions, in 1961. So it is standard code for designation of steel, correct? So for the purpose of code designation, steels have been classified on the basis of what? Mechanical properties and chemical composition. So steel are classified on the basis of mechanical properties and chemical composition. So code designation on the basis of mechanical properties is based on what? Tensile strength and yield strength. It may be given according to tensile strength or yield strength, correct? So we'll see one by one examples here. So part 1 is based on what? Letter symbols. The part 1 is having some letters and part 2 is having some numericals, correct? So first example here, it is Fe200. So what this means? Fe200 designation means steel with minimum tensile strength. Minimum tensile strength of 200 Newton per mm square. So here 200 means what? Minimum tensile strength of 200 Newton per mm square. And Fe means steel. So here letter symbol is nothing but Fe and numeral is 200, correct? So second example is FeE225. So steel with minimum yield strength of 225 Newton per mm square. Now here E is there. E shows us yield strength. E means yield strength, minimum yield strength, and its value is 225 Newton per mm square. Now third one is Fe200K. Now here K symbol means it is skilled steel with minimum tensile strength of 200 Newton per mm square. 200 means 200 Newton per mm square minimum tensile strength, correct? Here E symbol is not present, that's why it is tensile strength is there. Now next is fourth one is ST42. ST42 means what? ST42, ST means steel with minimum tensile strength of 42 kg per mm square. Now here symbol used is ST. So symbol ST is used when tensile strength is in kg per mm square. When the tensile strength is given in kg per mm square, at that time we use ST. Or if ST space E is written, if there is STE 42, then we can call it as steel with minimum yield strength of 42 kg per mm square. So E means yield strength. Okay, so ST means kg per mm square unit. Now fifth one is C20. C20 is nothing but steel with average carbon percentage of 0.2%. Average carbon percentage of 0.2%. Now, actually, designation of steels consists of numerical figure indicating 100 times the average percentage of carbon atom. Whatever average carbon percentage there, it is shown by 100 times. So in this steel, 0.2% steel carbon is there, 0.2% carbon. So its 100 multiplication here, it is 20. So it is indicated by C20. Or you can remember in reverse manner also. If C20 is given, divide 20 by 100, you will get the carbon percentage, that is 0.2%. So like this, for carbon percentage you have to divide by 100. Now sixth one is 25C5. 25C5 means first two numerals are nothing but for carbon. So steel with average carbon of 0.25%. So divide 25 by 100, so you will get 0.25% carbon. And next is C5. 5 means here manganese is there, manganese percentage. So for manganese percentage, you should remember that you have to divide by 10. So manganese of 0.5%. For manganese, you should remember divide by 10. Now 7 number is ATT11. Now here T means tool steel. This symbol is for tool steel with average carbon percentage of 0.8%. Divide again 80 by 100, you will get 0.8%. And 11 means what? Manganese. That divide by again 10. I told you earlier that for manganese you have to divide by 10. So it is 1.1% manganese. Now next 8 number example is 20 nickel 55 chromium 50 molybdenum 20. So here you can see steel with average carbon of 0.20%. So first numeral is for carbon. So divide by 100. Nickel is 0.55, again divided by 100. Chromium is 0.50, again divided by 100, and molybdenum is by 0.20% divided by 100. So like this, these are examples are there of Indian standard designation system. So again, I would like to tell you that there are few examples are also. So let us consider that suppose there is example is like this. Sometimes it is shown that chromium 65 and there is underline below both the numbers 6 and 5. Then you should divide by 100 if underline is below the both the numerals. Then chromium percentage is 0.65%. Correct? So its answer is 0.65. You have to divide by 100 when underline is below two numbers, means you have to take 00, 100. Correct? This is one example. And if example is like this, nickel 13 and below only 3 there is underline is there. Correct? So you have to divide by 10 here. So what is percentage of nickel here? 1.3%. Okay, so depending upon underline, if underline is only one place, then you should divide by 10. If underline is below two numbers, then you should divide by 100. So like this also one method is there. So we'll see now next method. Next method is nothing but AISI or SAE Designation System. So AISI means what? American Iron and Steel Institute. American Iron and Steel Institute. And SAE means what? Society of Automotive Engineers. Have almost similar method of designation of steel and is based on chemical composition of steel. So both the designation system have same method actually, and it depend upon chemical composition of steel. So the system consists of designating the steel with 4 or 5 numerical digits. So there are 4 or 5 digits. The first digit indicates the type of steel. Whatever first digit is there, it indicates type of steel. The second digit indicates approximate percentage of predominant alloying element. The second digit is alloying element, predominant alloying element, which is maximum. So that is alloying element. And last 2 or 3 digits divided by 100 indicates average carbon content. And last 2 or 3 digits indicate what? Average carbon content. Correct. And sometimes it includes a letter to indicate manufacturing process of that steel also. How steel is manufactured, that is also included sometimes. So like A, B, C, D. A is for open earth alloy, B is for acid Bessemer. So like this method of manufacturing are also included sometimes. Correct. So we'll see the table is there one. So this is AISI SAE Designation System table. So here first you can see here, first it's carbon steels, correct? Carbon steel is there. So for carbon steel, the first digit is indicated as 1. Carbon steel is having 1. For plain carbon steel, it is also 1. First letter, you check for only first letter 1. First letter is 1 1 1 for carbon steels, correct? Now plain carbon steel consists of 0 alloying element, that's why here it is written 0. Second digit is 0 alloying element. Free cutting steel consists of some alloying element, that's why there is 1 is written, 1%, or it may have 2% also, so that's why second digit is 2. And manganese steel consists of some 3% manganese, so second digit is 3. So you should check that first digit is nothing but what? First digit indicates the type of steel, that is carbon steel is here in this case, and second digit indicates approximate percentage of predominant alloying element. Predominant alloying element. Similarly, second case here it is nickel steel. Nickel steels are indicated by digit number 2. It starts with 2, and depending upon alloying element, the second number is shown. Now here it is 0.50% nickel. So as it is less than 5 or closer, less than 0.5 or closer to 0.5, that's why we should take it as 0. So it is taken here 0. Now here it is 1.5% nickel, so it is again less than 0.5 or equal to 0.5, that's why we have to take now 1. So as we do in numericals, we approximate the numbers. So same thing here it is done. Now here it is 3.5, so we should take 3, and here it is 5, we should take 5. As we do, if there is 1.7, then we should take it approximately as 2. If it is 1.4, we'll take it 1. So like this, here 1.5 is there, so we have taken again 1 here. So like this, there is nickel steel is there. Similarly, nickel chromium steel is there, third one. Nickel chromium steels are indicated by number 3, and their various combinations are from number 1 to number 4 for second digit. Fourth number is molybdenum steel, so it is indicated by 4 number series, and the alloying elements are shown by 1 3 6 8 depending upon their percentages. Chromium steels are indicated by 5, chromium vanadium steels are indicated by 6, tungsten steels are indicated by 7, nickel chrome molybdenum steels are indicated by 8 series, and silicon steels are indicated by 9. So in the silicon series, 2 is for manganese. Sometimes manganese is also there. So this is silicon manganese steel series is there. Okay. So here you can see there are some examples. So first example is 1040. So one means one means what? Carbon steel. One is carbon steel. Now second digit is 0, that is plain carbon steel, no alloying element, and divide last two digits by 100, that is carbon is 0.4 percentage. Correct. The second example is 2440. So here 2 means what? Nickel steel. Second digit 4 means what? 4% nickel, and divide 40 by 100, you will get carbon as 0.4% carbon. Third series is again 10 means plain carbon steel is there with carbon percentage of 0.1. Divide 10 by 0, divide 10 by 100, you will get 0.1%. Fourth number is 1035, that is again plain carbon steel with carbon percentage 0.35%. Fifth number 1095, plain carbon steel with carbon percentage 0.95%. Sixth number is 1112, that is 11 means what? I already told you in last slide, that is free machining steel is there. If there is 1 is there, and 12 means 0.12% carbon. Now next, that is 1214. So 1214 means what? Here there is 0.12% carbon, 0.14% lead, and that is free machining steel is there. That is free machining steel. Correct. So next it's 1330. 1330 means what? Again it is 1 means what? Carbon steel is there. Carbon steel. 3 means what? Here it is magnet steel is there. So magnet steel means 3 means magnet percentage is there 3%, and 30 means there is 0.3% carbon. Correct. So you can see here 1 means what? Free machining steel is there. 1 means also free machining steel, and 1 means magnet steel is there. Correct. And 10 means plain carbon steel. So you should remember all these things. Now next example 9 number is 2317. 2317 means what? 2 is nickel steel, 3 is nothing but nickel percentage is 3%, and 17 means carbon percentage is 0.17. Now 10 number example is 9260. 9260 means what? 9 means I already told you, that is 10 means silicon steel, 2 means silicon percentage is 2%, and 60 means what? Carbon percentage is 0.6%. So like this is AISI oblique SAE designation system. So both the designation system have same method to designate the steels. Correct. So now third method is there, British Standard Designation System. So this system is used to designate steels in British era and is also known as EN series. It is denoted by EN. EN stands for here emergency number, since it was developed during World War number 2. So it is represented as EN, and there are some numbers are there followed by numeral. The EN number does not have any correlation with the composition of mechanical properties of the steel. So here there is no correlation. You will find in this series there is no correlation. These are only emergency numbers. So these numbers are used to designate emergency, in emergency only. So you will not find any correlation with the chemical composition as well as mechanical properties. So you can see here. So here EN1, EN8, EN24 and EN36, like these examples are there. So basically you can see that here carbon percentage is 0.07, here 0.35, 0.45, 0.15, and some alloying elements are here added. So actually there is no any good combination, or we can call it as there is no much correlation with mechanical properties or with the composition. So you are, in this case you have to remember all these things. What is EN1, what are the compositions, what is EN8, what are the compositions, or it is sometimes in increasing order also, some percentage are increasing in the order. So like this you can remember. So here it is less carbon, here more carbon, here more, again it is more. So like this. And again there are some examples are here. EN42 is there, EN353 is there. So like this, these are some examples of British Standard Designation System. correct? So like this we have learned today the specifications of steels, or we can call it as designation of steels. So thank you friends for watching this video. Thank you so much for listening this video. Please like and subscribe my YouTube channel. Thank you.